Okay, welcome to episode 6 of the OpenStack Now podcast. We are thrilled to have with us today Lew Tucker, VP and CTO of Cisco, and all-around nice guy. Thank you so much for joining us, Lew.
Great to be here, Nick. But let me correct you. I'm CTO of cloud computing at Cisco. Cisco is a really big company. We have CTOs in different parts of the company. Dave Ward is actually much more overall CTO for engineering.
Well,
So I'm just in the area of cloud computing.
You're just a little CTO in a big company.
You got it.
I'm glad that you actually brought that up because that's something that I wanted to talk to you about. Every person that I talk to says, whenever I mention you, they go, he's such a nice guy. Every recommendation that I see, he's just a fundamentally decent guy. And when you think of big companies, you don't think of that. So basically, what's a nice guy like you doing in a big place like that?
Yeah, exactly. Yeah. Well, in fact, I'd say, it's the part of the company that you're in or the part of the technology. As you know, I've been very active in open source and community development of software. And I think there's a lot of nice guys in that. I think that actually coming out of like Sun Microsystems and where you've had other people, I know that you had Adrian Cockcroft on recently or whatever. There's a lot of really nice guys because I think, we have to work together. And so a lot of what we're doing in OpenStack and open source is really about forming those relationships so that we can do this kind of development in a way outside of our companies so that our companies can benefit. But yeah, so it matters whether you can really work with other people. So I'm very glad to hear. I'm very flattered, actually. So thank you.
That's good. John, you were saying something like that.
Absolutely. I mean, the culture of open source is clearly based on relationships, and that was my first impression when joining Mirantis as an example of a very, very open company was the universal cordiality. For that to exist, in the same context as extraordinarily high pressure, high stakes development decision making, and a lot of balls to the wall coding. I mean, the reality is that people work very, very hard in this business, as they do, elsewhere in technology too. People manage to contain themselves, though. They manage to believe the best of each other, and this works over astonishingly well, even over broad distances, different timetables, and international cultural barriers.
The other thing that I think makes it work is that it is. OpenStack actually started as a very small community. And in cloud computing, in fact, over the last, 8 or 9 years, it's been a small community. So we've gotten to know each other, whether it be at conferences or I remember being on a panel with Simon Crosby. And he's one of the smartest guys I know. And so, with what he's been doing with Chromium and everything else, it's been amazing to see him interact on a panel because we can be very, very deep and we can have very strong opinions about things. But then you're recognizing you're with other people who have equally strong opinions, and we all have this goal of trying to advance the forefront of technology going forward. So that's a common goal that keeps us together. And then we compete like crazy in the marketplace. We all have companies that we're trying to advance. But when we get together in terms of trying to work together either on standards bodies or in open source communities, we know we've got to work together. And you have to be able to, for example, when I bring in new developers into Cisco working at OpenStack and they've never had any experience with it, the first thing I tell them to do is review other people's code. One, you get to learn. The second is you're creating those relationships. And so if you're helping other people advance what they're doing, it'll come back to you. So pay it forward. And I think that's the way it works in this industry today.
Well, that's good. So, and that notion of everybody kind of working together and all of that, and you talked about, the smartest guy in the room. There's a lot of smartest guys in the room. I mean, this is a very, very smart community. And it seems like you can't swing a cat without hitting somebody from Sun. I just found out before this interview that John worked at Sun, and then I remembered that I worked with John on Sun stuff.
Yeah. The Sun Diaspora, I think, is alive and well in Silicon Valley, and Sun was one of those places. I think that we, it was, first and foremost an engineering company, and it was, trying to solve some of the hardest problems and cutting edge technologies and everything else. And we went through different periods of our own evolution, breaking up into a series. We tried different business models. We've tried, we open sourced a lot of our technology. We distributed Java. I remember being a part of the very early Java team, and we were trying to figure out, well, how, here we have this new language. We had designed it for a set-top box. And now we found it fit really nicely inside of a browser. And so we'd called it like Mark Andreessen and said, hey, let's get this into Netscape. And it was that kind of connections across the industry that allows a lot of these technologies to make their way into the market. And so now I think that when, Sun now is a part of Oracle. And so we still have friends now within Oracle, but we also have all of these other friends in other companies. And that's what has also made Silicon Valley work so well, is that there is, in many ways, this like roving band of technologists that move from company to company, and they still have these relationships, and they still get together with different people that, we're able to exchange those ideas, and that's what makes it work. It's very different. I noticed a big difference moving actually from the East Coast to the West Coast. On the East Coast, I was back at a company called Thinking Machines back,
Oh, wow.
with MIT and other places. And it was coming out of sort of the DEC, Digital Equipment Corporation technology. Everything was, we were competing with everybody. And moving out here, it was, no, you're cooperating with everybody. That's how you make, progress and everything else.
Was Thinking Machines Danny Hillis' company?
Yes, it was. Exactly. Oh, okay. Very good. Yeah, we built a connection machine. So, we had the world's fastest supercomputer for a while, 65,000 processors. Yeah. Try writing code for that machine, I tell you. We had to invent new languages, parallel languages to have, to run these very, very large problems. And that meant we had to do our own chips, our own compilers. So we did everything, from hardware to software, to selling of the machines and putting beautiful blinking lights on it, because it was a rather expensive machine. It had to look really good. but now actually you can do, it's about the power of an iPhone or a couple of iPhones stacked together today. Yeah. Moore's Law. It's great.
It's amazing. So speaking of, let's talk technology for a minute, and then I'm going to swing back around and go back to the doing everything, to the doing everything notion. So let's talk a little bit about what Cisco is doing in OpenStack and the Internet of Things and the intercloud, which I'm just going to go on record here as saying, hey, that sounds a lot like the speech that I gave at the summit about the worldwide cloud. Just,
Yep. Hey, there are no new ideas, nothing's truly original in this highly collaborative environment.
It's true.
We're all riffing off of each other's, latest thinking. So
that is very true. I put the proposal in, and then like a month after that, I saw the intercloud, and I was like,
yeah, we just beat you to the press release.
Okay. Yeah, you beat me to the press release. Yeah, but I've got prior art, my friend.
Okay, good. We'll talk.
You watch. Nick becomes the patent troll.
We do too. Yeah.
Yes, that's it. I become a patent troll. It's my next career.
Yeah.
So,
but, it is interesting because, several years ago when OpenStack was just getting started, and I had come in, I've been at Cisco now 5 years. And coming into Cisco as CTO Cloud Computing, I was really saying, is cloud computing a threat or an opportunity for Cisco?
Yeah.
Everybody says, oh, it's a huge opportunity, all this bandwidth, all these switches and routers. Cisco's business is going to grow exponentially because of cloud computing. And I was a little more cautious, going, well, most of the cloud computing I know creates another layer. And so another layer that really puts an application even further away from the infrastructure. So as an infrastructure company, Cisco needs to start to move up that software stack. And so we needed to start making those investments. And the best place I saw for us to do that was in helping to grow what was very, very small community there around OpenStack. Because that way we're essentially getting in and on the formation of a new cloud platform. And therefore, we contributed a lot in terms of the networking service, originally called Quantum, now called Neutron. But across the board, now a lot of it is moving into containers because we're seeing cloud computing as being this huge disruption in the industry. As we all know, I mean, this is not original thoughts by any means, and that we know these clouds are becoming connected, as you've talked about.
Yes, absolutely.
So understanding how, what are the systems that we need to build this platform going forward to serve Cisco's customers is primarily what I considered my task to be. So we quickly started a group, and OpenStack started contributing very heavily, and built that up over time. And then most recently, it's been manifest in terms of a Cisco service called Intercloud, which we're doing with our partners.
Which I think is a great idea.
It's a wonderful idea, Nick. It's just, an idea whose time has come, okay?
That's right. Sorry. And let's talk a little bit about ACI and how you see that kind of like fitting in.
Yep. So well,
first of all, explain what it is.
Yeah. Okay. So ACI is application-centric infrastructure. We really are saying that as we keep creating these different layers in the software stack, and the purpose for that is to make it easier and easier for applications to be built and to be constructed. We're not, writing assembly language code anymore. We really are building on top of other services. And so when it comes down to now the infrastructure, what we want to do is reflect the needs of the application down into the infrastructure so the infrastructure can do the right things. So traditionally, this has been thought of in terms of creating isolated networks for different applications or prioritizing traffic, having quality of service. If you really have a video stream you're trying to optimize for, or if you have a database that you want to be able to have really fast access to, you want to be able to have the application inform the infrastructure for what it wants to do. So in OpenStack, this has been manifest as group-based policy. Because as you know, and this is where traditionally, we've been describing, simple like web applications, 3 tiers. You've got a front end, you've got a middle tier, with application servers, and you got maybe a back end, which is data storage. And what we really are finding is that developers have a hard time or don't do it very well when they have to figure out all the IP addresses and what, security groups can talk to what other groups. And they would prefer to have sort of a contract in which they're expressing the policy. My database or my backend database servers or whatever should never be connected to the internet. There should be no path from the internet to my backend server. The only path, the only applications, the only nodes that can sort of talk to that are those that are running on my app servers. So that by having a developer create a language, and this is why group-based policy and OpenStack and other models for how do we express that policy, and then the infrastructure just makes that happen. And so this makes it much easier because most of the application developers, you want focused on the business logic of their application, what they're trying to do, the best user experience. They don't want to have to know about the plumbing, but we want to connect what their intent is into the plumbing, and that's what ACI is really about.
Gotcha. Okay. John?
So it sounds like part of the research that Cisco ended up doing in order to create ACI involved, natural language to artificial language kind of compilation.
Someday I think so. I think ultimately we would like to be able to get there, but today it's much more trying to formally describe through YAML expressions and through templates the intent, and being able to make it very simple for a developer to say, I have a group which is my front-end web servers, and I have another group which is my middle tier. And now talk about what policy do you want between those two things? That this kind of traffic will be supported or this kind of traffic will be blocked. Make it very, very simple to a developer to write a descriptive file, which is essentially being able to describe that policy. And then we can make it so that as you add more more VMs or components into those layers, that same policy will be applied. Because in the past, where problems have always arisen is that now you add, you change the number of application servers or web front ends, and you forget to apply the right ACLs or whatever to that, and you have a problem. And so by formalizing this into a very simple, language around policy, we can make that communication happen. But, that's only one part of what Cisco is really doing. And I think that as we look forward to, particularly, you've seen some of the new announcements around Google joining OpenStack and around containers and everything else. There's more that we're trying to do to make it easier and easier for developers to develop these applications, because web scale applications, remind me back in the thinking machines days, are large distributed applications. And that's tough. And so we really are trying to find a lot of these other programming frameworks to make it easier for those kind of applications to be built.
Excellent. And which brings me to my next question. Thank you so much for the beautiful transition. So let's talk about containers. And,
Sure.
You're going to be at OpenStack Silicon Valley next month. So we kind of wanted to get your perspective on, the news, with Kubernetes and Google joining the foundation and all that. So hold forth, please.
Sure. It's interesting. I think that, in trying to put together my thoughts about what would be an interesting conversation to have at the upcoming summit, I thought it'd be good to again look at the kind of disruptions that are happening in the industry, and the disruption that is not only, we're seeing these new applications that are being developed where, like, Uber becomes, this intermediator between contractors who are driving cars and people who want cars through a simple app. That happens now in IT. And so even organizations such as Bank of America and things like that are looking at their entire IT infrastructure and saying, why does it take me so long to bring up new applications? If I need to now open up a branch in a shopping mall, why does it take me so long to get all the infrastructure necessary to do that? So they're increasingly looking to become this kind of software-defined, software-driven infrastructure. And so a lot of talk is around this. So what do you need to do that? Well, you want to have it, you want to containerize your applications. You want to make it so your applications can run in many, many different places. So I think that with Docker and a lot of the container work over the last couple of years, Linux containers have been around for quite a while, we should remember.
Yes.
But now we finally recognize what was so important about it, which is the fact that it does give you the ability to have this kind of portability of applications from platform to platform. And so a lot of the intent behind the announcements between Google and OpenStack and Google joining OpenStack has been around making it so that applications can run on Google's compute engine and they can also run on OpenStack. And so I think that's key to this whole sort of transition we're seeing.
Gotcha. And so you don't, it sounds to me as though you don't see any sort of existential threat to OpenStack from containers.
No, it's funny. I think actually at the last time I showed this picture of like two boxers, because I think some people are often trying to say there's a war going on between Kubernetes and a containerized model and a cloud, which is largely a virtual machine model. And I don't see that at a fundamental level, because I think I see these things at two different layers in the stack. And I think that they have very different purposes. And what we're doing with some of the projects within OpenStack, such as Magnum and Cola, is that we're making it so that they coexist and they work together beautifully. So you can run containers on top of virtual machines. Magnum, if you want to be able to run those containers on top of bare metal through Ironic, you can use that. So we get to do, again, get the advantage of containerization and the advantage of a multi-tenant environment, which is what a cloud platform such as OpenStack provides.
Excellent. So all of that sounds fairly complicated. However, I am going to...
Boy, that's sorry. I'm sorry.
No.
It's computers, Nick. Computers are complicated.
No. That's my lead-in.
Okay.
Wait for it.
Okay.
Now, of course, before doing this interview, of course, we research everybody.
Yep.
And what I found particularly interesting is I went down your resume, and what I see is CTO, assistant professor of neurobiology.
Yes, exactly. Okay. You found me out.
I found you out. But let me just, before you say anything, this is not so much you found me out, because what never ceases to amaze me is how many people come into this industry from somewhere else.
Yeah.
I have a degree in physics. My degree is not in computer science.
Yeah,
Okay,
yeah.
John, you're what, visual science, I think.
It was physiological psychology. Yeah.
Physiological psychology.
Okay.
So, it's how do you?
I think that's pretty natural, because computer science. I mean, I took actually I was an electrical engineer undergraduate and switched to biology. Actually in my background, I was a ham operator as a kid, and I was always interested in biology. So I've had these two themes in my life, I guess, around biology and hacking hardware and software systems. And so I've gone back and forth. And so, yes, for a while, for about 9 years, I was at Cornell Medical School in the Laboratory of Neurobiology.
Oh, wow.
Doing a lot of experiments, understanding neurogenic control of hypertension. And yet I was using computers to help me do that. Very early mini computers, in fact, paper tape operating systems and things like that, but they saved me an awful lot of work. So I used computers as a tool to help do a lot of the neuroscience research. Ultimately, I was that's what brought me more into artificial intelligence, trying to understand how the brain worked by, essentially putting lesions or, into a brain to see what areas you were affecting. I felt was oftentimes like trying to understand a television set by taking a screwdriver and slamming into the side, and the sound goes off and you go, oh, I found the sound center of the TV. That doesn't tell you very much. It works a lot better to try to understand it by building a model. And so that led me into artificial intelligence, which is what brought me to thinking machines. Artificial intelligence, we could only explore having vastly larger computing systems than we had at the time. This was back in the early 80s. And so we had to build a very large computer with thousands and thousands of processors so we could start to look at artificial intelligence. And so each one of these things, computers have been a tool. And so I find it interesting. I've seen people from medicine. I've seen people from the arts and sciences. And computer science is really about imagining what's possible. So I think we welcome all comers. I mean, that's what we're looking for here.
Definitely.
And meanwhile, think of the number of brains that we haven't been lesioning in the meantime.
Exactly right.
Because we've been able to hack on, computers
right.
that don't scream and sue and do all that awful stuff.
That's right. And I think we're beginning to just see. I mean, it's some of the work that I was doing at Thinking Machines was in terms of machine vision. And so I was working on some of the early autonomous vehicle stuff. Now we're seeing Google cars. I was behind one the other day. I'm going, great, there's my work. Driving in front of me, with some engineer sitting there with a notepad instead of his hands on the wheel. So
yeah, that's
interesting
it.
times.
And it seems like there's a lot of the same kind of thought behind a lot of what you're doing now as there is in the sort of neurobiological processes and things. I mean,
yeah, I think so. And it's been, we're beginning to have the computational power and the data sets. Most importantly, it's the amount of data that we have now available. When we were trying to do some of the early AI experiments, we had so little data. It was very hard to learn. And we're now seeing sort of learning algorithms being put into systems. And this is where open source comes in again, because in my group, I have a lot of different projects going on. And one of those is around a lot of data analysis and everything else. And we've built pipelines out of open source components to do different machine learning algorithms. So we have this now componentry that's available in open source that allows new college grads to come out and they can connect up these different systems and produce something that can start to not only just analyze data, but learn from that as well. And
That's awesome.
So the tools that we have are just phenomenal now for people who want to go into this kind of work.
That is great. So now I'm going to drop a little bit more prior art based on that. Okay, so I'm going to predict right now. I'm going to predict implants that go in your brain to enhance your cognition that you can download open source improvements to.
Okay.
There you go. Okay.
Very good.
There.
So that's why instead of, artificial intelligence, it's always been about intelligence amplification.
There you go.
And so that's exactly what you're talking about.
There you go. Well, what do you think is coming in the future?
It's funny because as a CTO, you've seen a number of those jobs. We're supposed to be able to look around corners, and and that's somewhat true. I think that the next couple of years, almost all of us are able to see the sort of next couple of progressions, and then it gets very fuzzy very fast. So I think that Moore's law is continuing to drive increases in performance and driving down cost. I think the revolution that's happening now is a move in the software space around how applications are constructed. For example, microservices. People are talking about things as microservices. And what that means to me is that let's stop building large, fragile, monolithic applications. Let's make an application out of a set of these smaller services.
Yes.
To me, that's much closer to actually a biological approach, which is that you have different functions that are communicating, and out of that communication emerges the intelligence or whatever. So rather than trying to program in that, let's make these microservices and assemble these applications, which means they can continue to grow. They can continue to improve. Right now, those improvements are all mediated by humans. Soon, I think that we can start to see some of those things happening automatically by machine learning algorithms and things like that. But it starts with being able to encapsulate functionality as a set of services that are driven by an API.
Right.
And so you don't have to know what's in that black box of the service. You can access that service. Amazon, I think, was in the forefront of that when you looked at Amazon's web services. Every 6 months or every several months, Andy Jassy would be out and he'd be, here's a new service that's coming out. And that made it so much easier for people to go and build big things, such as, Adrian's working on Netflix, so you can build a lot of these much larger services much faster, built upon these other smaller services. And now we're doing it at another level entirely with containerization.
Excellent. John?
This is, I concur what he said.
Mm-hmm. Okay, so let me add to it. Let me add to it as well, because it's not happening just in what we think of traditional consumer-facing web applications. I mean, that I think is continuing to, we're all consumers of that, so we see it every day. But now we're seeing it in what's known as network function virtualization. Mm-hmm. We're seeing it happening, I think, increasingly we'll see it start happening in the video space. I was at the National Association of Broadcasters show in Vegas a couple of months ago, and that's where, you have the largest companies that are doing all the video encoding, transcoding, storage for streaming television, for live TV, for broadcast, and everything else like that. And it's been largely hardware-based systems that have been specially built to perform those functions. That's now being virtualized. That means it's becoming software. That means there's a whole new set of companies that are going to start moving into that space based on software running on top of a cloud computing platform. This stuff is moving to the cloud, whether that cloud is on premise or at a service provider. That's the disruption that's happening because of the movement of, as Andreessen said, software is eating the world. These things are moving from hardware-based systems to software-based systems on general purpose infrastructure. And that's this bigger movement that's happening. And that's the disruption, I think, that is sweeping through. So it's going through all the major telcos today. We're going to start seeing it hitting all the major media companies. We've already seen at the summits, several of those companies talk about what they're doing on OpenStack. So I think that's the disruption that we're happening because of cloud computing. And we're just still at the very beginning of that.
Absolutely. Well, Lou, I wish we could just go on for hours and hours and hours, but we can't, unfortunately.
This has been great.
I'm really glad that you think so, because I personally have had a wonderful time, and I really hope that you will join us again soon. But for now, we will have to take our leave, unfortunately. I will remind everyone that Lou is going to be speaking at the OpenStack Silicon Valley Conference in August. You can get tickets at openstacksv.com. Please go ahead and join us. And join us at OpenStack Now by hitting us up at subscribe.openstacknow.com. And you can see the podcast at podcast.openstacknow.com. And you can tell my penchant for or penchant for just using subdomains rather than long URLs. Anyway, I want to once again thank our guest Lou Tucker from Cisco and my co-host John Jainschigg from Mirantis, and I am Nick Chase, and we will see you again next week. Thank you all so much.
Thank you, guys.
Bye-bye.